Hello, everyone. Thank you today for joining us for an easy workflow for a road design project in West Africa. We are going to be demonstrating using RoadEng Civil Engineer software. This seminar is going to take you through, as I said, a quick road design project. We are going to start with the import and modeling of total station survey data through to the creation of construction documentation and quantity estimates. Now, I have to say, there is one slight change from our original plan today. We were originally planning to work with some total station data located in Nigeria. However, we've got a really awesome set of survey data that's been handed to us from Sierra Leone, and we're really excited to get into it. So, just to kick things off, I'm Erin. I am going to start with a little bit of an introduction. Then I'm going to pass it over to my colleague, Matthew Dickey, and he is going to take us into RoadEng software and actually show us what this workflow looks like and how to work with that data. So I did mention we are working with RoadEng. It is a standalone, easy-to-use civil engineering software. It does not require any CAD platform to run it, and it is fully standalone. It is particularly great at rural road and infrastructure projects. Secondly, in terms of webinar housekeeping, you are all muted, and we're intending to keep it that way, but please ask us questions at any time. You can do so using your GoToWebinar panel, and you can just type your questions in the Q&A section there. All question askers do remain completely anonymous, so we won't say who you are, but we will read your question out loud and address it here in the webinar. Okay, so let's quickly go through a typical rural road workflow. So we do start by importing our survey data. So in this case, we're going to use total station, but other possible sources of data include LiDAR or GIS map data, such as a shapefile, or even data coming from another design program like a DWG file, DGN, etc. But as I said, today we're going to start by importing total station data. Inside of our terrain module, this is where we're bringing this data into, we do create some break lines and other linear features are connected and identified. And then from here, we create a TIN model, so a triangular irregular network surface representing our original ground. We can also create contours at this stage. We save that file and it is called, we save that file and it becomes a terrain file that we're going to reference in our next phase of the workflow, which is where we create a new location design. So location is our road design and corridor design module. We reference that terrain file as our starting point. From there, we can set up our cross sections. We can click in our horizontal and our vertical alignments. We can calculate our earthwork quantities. The software itself actually has a whole bunch of reporting options in addition to our plan, our profile, and our cross-section views. These different reporting tools give you some visual, give you feedback, and that can include volumes and the mass haul diagram. And we'll show you a little bit about those today. We calculate our costs and quantities, and from there, lastly, we can create construction drawings and output sheets. Now, obviously, there's a lot more little steps you can include if you'd like to, but this is the typical basic workflow that we are going to follow. Before I pass it over to my colleague Matt, I did just want to say a quick thank you. First off, to our official distributor and our partner based in Nigeria, KeyCam Technologies Limited. Once the webinar is done, we will include in the follow-up email a link back to their website and some of their contact info. They are a great local partner and a great source of local information. So thank you to them for helping to put this webinar on today. And then secondly, thank you to the Sierra Leone Roads Authority for the gracious use of some of their road data. And with that, Matt, do I have you with me?
Yep, I am here.
Awesome. I am going to pass it over to you.
All right. All right. Everyone see my screen? Can you see my screen, Aaron?
You are all good.
All right. Excellent. Well, thank you for the introduction, and we'll get right into it. Quick item to note, if you install RoadEng, you will find two icons. So it's modular software, and as Aaron introduced, we're going to start by working in terrain. The survey data that we're going to work with today is in CSV format. So just before we get into things, let's take a quick peek at what we have. So we have a point number, coordinates, elevation, and a point code. And the way this data was shot, we have our point codes, and if this B001 represents a break line, we're going to isolate that as one break line versus B002 as another without having to include each individual number. So that'll make more sense as we get into it, and let's get into it. So I'm going to open the terrain module. I'm going to click Insert File, and we'll navigate to that CSV that I have. And typically, if you started without setting up what we call an IOP file, you'd have options to import ASCII text or ASCII LiDAR. So if I do this, I would have to specify which coordinate's my x coordinate, which column's my x coordinate, which column's my y coordinate, which column is my z coordinate, and which column is my point code. And then I could come over here and start defining my codes. Now you'd only have to do that once. After you did that, we could hit save as default, and that would be configured on input or configured on its startup. Now, I've done something a little different here. So I've gone through and I clicked new format previously. I've clicked add, and I made one of these IOP options. So our software system settings are set up so we can match the survey standards that were followed and really streamline the process. So I'm going to go down here. I've called mine West Africa webinar, and there X, Y, and Z are set. I've got my point codes defined here. So as I mentioned, the B001, that's going to be accounted for with this B star. So this B captures what it starts with, and then this star is represented as a wildcard character. So anything that comes after B, it will be treated the same as far as symbology and properties go, but they'll be isolated as different features. So anything that starts with B is going to be a solid black line. It's going to be treated as a break line in our model. It's going to be connected. It's going to be displayed. Whereas something that starts with C, as in center line, will be a blue line. Now, other options we have here, we can test to make sure that we're reading in that data appropriately. We can, if we had a really dense data set such as LiDAR, we could thin that data down on import, but total station data or RTK survey data, you'd almost never want to thin that data. And we can set our projection. So in this case, my projection is UTM zone 29 north, and that's what I want to keep it in. But if we wanted to switch to another coordinate system, we could. And we could do that by using the drop downs or defining it based off EPSG or the coordinate system in WKT format. So I'll hit OK. And we have our data. Now, when we first bring that in, it's all magenta, and that's just because everything is selected on import. Now, if I click off to the side, we can see what we're dealing with. Now, with this, right now, we just have a series of points and lines. We don't have a 3D surface. If we want to create a 3D surface, we'll click Terrain Modeling, Generate, And here, whether we make contours or not, that's optional. I'm going to do it in this case just because it adds a little bit of extra context. And I get a warning that I have crossing break lines, which I'm not too worried about. We can either clean that up, or depending on how fussy you want to get, or not at all. I'm probably going to ignore it in this case. So we've created a surface. Now if we click that 3D view, we can see exactly what we're dealing with. Now here I can see one of our break lines is right there. So I can start cleaning my survey data. Now this line doesn't add anything, so I could, actually I'm going to delete it. And for example, if we wanted to add a new feature, let's do this here. And I wanted to make something that was a break line. So just to add in break lines to control the triangulation, I can do that. I'll turn that on. And I'm going to go from here to here to here to here. So I've created a new break line feature, and we can include that in the model. So to remodel that, again, generate. And away we go. I've got a bit of a berm there. Now we can modify existing points if we'd like. So here, just to illustrate, I'm going to break that and modify. Let's explode this. And of course, we can go through and we can play connect the dots. So at that point, I'll hold in Shift on my keyboard, do our multi-select, and now I would normally use the hotkeys, which would be Control Join to join those, but we can come in here and click Join as well. And we can click Model again and update that surface. Now, if for some reason we wanted to change our symbology, that's easy to do. We can come over here and say, rather than a tick mark, let's add in triangles at our points. And if we wanted to change how the properties are set for that feature, we could change that here. And I'm going to join these two. So, just to be safe, I'm going to save this, and we'll call it topo, and we're going to refer to that in the future when we switch over to do our actual design. Now, another useful feature, if you don't have your own ortho imagery, we can pull in ortho imagery from the web. So for that, I've got my feature selected. Since on import, we set the coordinate system we were using. I'll click import. And there we have access to web map tile services from Bing, Google, and MapTiler. So if I want to use this imagery, I can. And if I just hit save right now, it would grab my whole extents, which I don't really want. I'll crop what I'd like. I'll hit save. And that's going to download that imagery locally onto my computer. And then I can have that in the background, which will add context for when I'm designing. It's also a nice feature to use if you're playing connect the dots and not 100% sure what points should be connected with what. We'll just give this a moment to think. And once that's downloaded, we will switch over to location. In fact, we can do that now just while it thinks, and then we'll bring in that image after it's downloaded. So we've saved this terrain file as topo. In location, I'm going to click this little green icon for file. And a lot of folks that first open up the software, they want to click open to reference that terrain file. Now, it's a different format, so we're not going to click open, we're going to click new. And that back into terrain, that image that we've downloaded is done downloading. So I'll hit save. And there we are, we can see the background for what we're dealing with. So anyway, back to location. I'm going to reference that topo surface. I'll hit open. And if I wanted to, I could base my initial alignment off of a surveyed feature. Now in this case, I'm not going to do that. I'm just going to start with a single point to show how the general behavior of the software works, and we'll click in something entirely from scratch. And there, so my single point landed in the geometric center of our data set, but it's off the tin in this case. Now, before we get going too much further, I'm going to right-click Plan Options, and I'm going to add that image that we've downloaded in as a background. All right, so things are looking good. I'm going to move that start point to the start of our alignment. So I'll right-click, add Edit IP tool, come within the snapping tolerance of that point, click once to unanchor it. I can pan and scroll with the wheelie on my mouse, and I'll drop that right there. Now, before I start clicking in my alignment in any detail, I want to make sure my cross-section is appropriate. One of the big things about our software is it's dynamic. As we design our volumes and our different views are automatically going to be populated. To save having to go back and change our cross-section later, we might as well consider it right from the start. Now, for that, let's click Templates, and I have our default rural road template applied. Now, these templates themselves are more of a carrier of information. So the template itself, we can set things like our crown, control some global parameters, like if volumes are being calculated for it or not. But the bulk of the information is stored in the components that make it up. So we've got our rural left component, and this is basically a fillable form to control the geometry of what we're dealing with. And I'm telling it that I want my roadway to be a 7-meter road. That's 3.5 meters either side of center line. Applying a ACP thickness of 15 cents. And we can go down and look at all the variables. Now, and that stays true for everything. Now, if we had something that wasn't represented well by the 3 default components or default templates or the components in them, we could click on the eLibrary and bring in a collection of components to make up what we want to work with. So here, for example, if we were planning to go through some large cuts and we wanted to bench those cuts, if we added our slope component into one of those templates, our slope 6 components, we can get bench cuts automatically accounted for. Now in this example, I think the default rural road is pretty applicable. Not overly familiar with the project, but at a glance, I assume it's largely a full rebuild, realignment. If it was a widening, we could go with the widening and plan accordingly, but we'll just stick with this default template. And since that was applied and we haven't made any changes, I just hit cancel, and there it is. So let's start designing our alignment. I'm going to start by tackling the horizontal. So again, I've already right-clicked in my plan view, clicked Add Edit IP tool, and To move an IP, we'll come within the snapping tolerance, click once to unanchor it, and click again to re-anchor it. Now to add on a tangent, we're going to go with outside of those snapping tolerances. So our cursor is a pencil, and we'll click, I double clicked, but I'll click once to add in a tangent, and I'm just going to roughly match up what I'm dealing with. And so in my profile, I hit zoom to extent so we can see that I'm falling off the tin here. So fall off the surface, which makes sense. I'm way out here to account for that corner. But let's keep plugging away here. I'm not going to design the whole road just for the sake of time, but we'll do a little bit. Let's come out to there. Again, and where we fall off the tin, as expected, our cuts and fills are going a bit nuts. Now, I'm going to click horizontal curves tab, and at that IP, I want to add a circular curve. I'll go with the 200-meter radius curve. I'll hit apply. Still not as sweeping broad of a curve as I'd like. Let's try 400. A little too kind of going for the premise of loosely tracking the current alignment. And now we can see we're back on the surface there. And we'll jump to the next. So I added a circular curve last time. If we wanted to include a spiral curve, we absolutely can. I'll go with the circle curve again here. 200 is pretty fitting. Now I'll hit apply. If I want that to be my default curve, which it already is, I'd hit set as default curve. And when I went to the next one, I wouldn't have to set anything, which I don't because it's already my default curve. And let's crank that up to 300. I'll change my default curve to 300. I'll set as default. And rather than going through and setting up each one of those remaining IPs, which I think I only have 2, I'm going to hit auto generate, apply default curve, and we saved a little bit of clicking there. Again, our profile is showing what we want to see. Right now, it's just the topo surface draped underneath there. And we can click on our, zoom in on our 3D view and see what we're dealing with. Now here in my 3D options, if I want to see that surface as a surface, so the topo surface, I'm going to turn on display triangles. And let's set that as being transparent. So 255 is fully opaque, so we can see where we're in cuts and fills, and looking pretty good. But if we look at our profile, there's some pretty abrupt grade breaks through there. Let's refine what we're dealing with there. So just like we did in our plan, I'll click Add IP. And I've got my grades showing. I'm using an exaggerated scale, so profile options. My scale is exaggerated by a factor of 10. I've got labels, grades are turned on here. And we can also, instead of defining off K values or length, we can let's automatically calculate the minimum K value based off our design speed and our site distance. So our site distance is being calculated based on driver limitations. We can hit apply, and there we've got the minimum K value to meet our site distance requirements. And let's just jump back here. And there is a way to automatically account for our vertical curves. I'll mention that at the end here. It's with a software add-on that will optimize your alignment to minimize your earthworks costs. And here I'm getting the warning the curve does not fit tangents. So I could either go with a smaller curve, or I can move my alignment so it works with the K value that I'd like to use. Now I've got things roughed in. Now if we look here now, our road alignment isn't, our center line isn't set right on the surface. We've got cuts and fills, and that's reflected in our cross section. It's reflected in our 3D, it's reflected in our plan view. So I can see my slope stakes where I'm in a decent sized fill here. My slope stakes are extended out. And our mass haul, it's automatically adjusting based off of what we have designed. So let's look here. So we're ending in a deficit. Let's try and reduce that deficit. We'll move our vertical alignment over. Now I've got too much of a surplus. Maybe it makes sense to add in another curve here. We're pretty close to balancing out here now. So we're within 700 cubic meters of balancing. We could spend some time and tweak that. I'm content with this for kind of demonstration purposes. So we have the graphic that indicates our surplus and deficit for material movement. Can we look at that information tabularly? Well, of course we can. So we have our data table. I'll click that. Oh, and mine is hiding on me. Let's just tile that. So there's our data table. I'm going to configure my data table. So data options. If I want to see volume summaries in 100-meter intervals, I'm going to turn on this. Now, if I wanted to change that 100 to be some other interval, I could. And I want to see design totals and the information I want to report. Let's show our station, and let's show our cut and fill volume. And we can also include the different layers that make up our pavement structure. So there we are. Our design, we can see that our total cut is 14,546 cubic meters, and our fill is a little bit less than that. And let's just jump back to the screen layout I like to use. Another thing we can do here is we can quickly add in culverts. We'll click that. We've got a culvert added in, and we can do that throughout our design. Now, once we are content with our geometry, we can switch over and produce an output sheet. So kind of that formatted design package, kind of CAD equivalent to paper space. We'll click this icon here. So this is our multi-plot editor. And I could go through and I could add in my different subviews, or again, CAD terminology, more viewports, and build a document from scratch. Now, if you didn't want to build a document from scratch, we could add in pre-formatted chapters that we've put together and put on the web here, or we can bring in a book layout. Now I've got a multi-plot book layout that I like to use, and I can use it on any project really easily. So I've got plan over profile, cross sections. I could add another chapter for my title page, another chapter for my notes, and any other information I'd like to include. And here I'm just seeing data not available. I'm going to add in a couple data tables. And there, my data tables are populated now. It's really easy to produce your drawings, really easy to do a good job designing. And if you have to share that information with a surveyor or switch over to another software, it's really easy to export that data. So save as, and we can change it to whatever format we'd like. So DWG, DXF, LandXML, and DGN being the most common formats to export it as. Oh, and also coordinates if you want to work in a point format to bring that into your survey equipment. But LandXML is a nice format as well for that, where it'll include all your surface data rather than just having to work with points. Now, one kind of extra bit is I mentioned that we can automatically generate this vertical alignment. And we can do that building on some design time costing that we have in the software. So in this design, I've just told it that I've got a single material that I'm using for cut and fill. Now we could add a bunch of different materials in there if we had different ground types that we wanted to account for. But the important thing is that we have costs assigned to those materials. So in this case, I'm just working with overburden, and I've told that it's going to be $12 a cubic meter to cut, $4 a cubic meter to place and compact. And if I had something like solid rock, obviously the value is going to be more. Now you can customize these values and you can add whatever ground types you'd like. For movement costs, we've got our haul cost schedule here where we define our hauling unit rates and loading unit rates. And that will be included in our costing. So we can click recalculate range, recost, and it's going to spit out a number here. So as designed, this section is going to cost about $250,000. Now, if we'd like, we can optimize it. Actually, and just for the sake of being able to compare the two, we'll click new. I'm going to tell the software to sample in 20-meter intervals. Standards, I'm just going to use curves fast here. So it's going to allow us to have curves back to back to back, which will give us the cheapest solution, but it'll be a humpy bumpy alignment. I'll tell it what we'd like for our minimum K values. I'll go 20 for that. If I have any control points, so at this point, when I want to start my alignment to be a control point. If I didn't think this would balance, I could add pits. Our unit cost we've already discussed. If I had anything that I wanted to constrain, like material movement for construction, if there's a certain direction that had to be moved, we could account for it here. We could allow it to sidecast material if we didn't want to haul it to a spoil site. We could say that if we're crossing some ground with poor structural integrity, let's give it a minimum fill depth. And those constraints would all be taken into account in the optimization. I'll just leave it unconstrained because this is unconstrained when I designed it by hand. We won't worry about those last few. I'll come over here to vertical optimization and I'll click process.
And while that is processing, I did just want to encourage folks who are here in the webinar, if you have any questions, this is a wonderful opportunity to type them in. There is going to be, I guess a minute or so here while Matt's optimization processes. So to ask the question, all you need to do is expand your GoToWebinar panel. There should be a little section in there that says Q&A, and you can just type it in confidentially, and we will address it at the end of the webinar.
Yeah, and I do see that there's a couple questions here. One is it possible to add multiple culverts at once? Yes, and I've got another design open here. So I kind of just briefly touched on the culvert editor. I added a single pipe, and I didn't really talk about the parameters in it. So let's say we wanted to add a culvert at this location. I'll click add. So that takes on my default cross-section, or sorry, default cross-drain settings. Now I can change that if I want to change my diameter. I absolutely can. I'm overriding my ditch right now. If there's a ditch to have at least a width of 1 and a ditch depth of 1 meter, I can change my structure type if I'd like. Let's just change this to be an 800. And there we are. Now, my gradient, I've set it so it's always going to be 5%. If I want to match the existing ground, I'll turn that to auto. The length was set to auto calculate. And if we want that to be rounded up, we can change that manually. And we can change our skew. We can change where that's positioned in the fill as well. So if we wanted to base it off fill depth, if we wanted to change our skew, we could do that here. And if we want to add multiple culverts at once, we can give a spacing and a number for that. Usually, I like to just add them by hand and choose the actual location. It's pretty seamless and you get lots of control that way. Another thing that I do use a lot for culverts is the 3D view. So we can see where that pipe is positioned, and if we had this set up to include our topo surface. If we had a surveyed feature or whatever for a draw, we could really line that up and get a perfect match for the existing ground. We'll come back to the next question there. I just heard a chime shortly after I started answering that question about our alignment. I'll hit OK. So this one is, again, it's going to be humpy bumpy with lots of vertical curves, but it gives us a cheap solution. So it went from $250,000 to build this to 150,000. We can zoom in, see what we're dealing with, and we can look at our mass haul here to see how closely we are tracking the existing ground for balancing those cuts and fills. Yeah, so that's what I wanted to show. And I guess the reason that I had this open in the first place was I've also optimized this. Now with this optimization, I did it for the whole thing. So that's the longer number or the larger number. But rather than using fast curves, I've told it to use variable curves and tangents. So I've told that it needs at least 40 meters between my end of one curve and beginning of next vertical curve. So it gives you a neater solution. It costs a bit more, takes a little longer to run, but if it's a highway, I'd lean towards using variable curves and tangents. If it was a low volume, low speed road, I'd lean towards using fast curves. Now, back to answering questions. Next question, does the software handle road widening or road widenings? Yes, it does. So I briefly mentioned that we can add in different components that do different things. So here I've added in a widening component. Now with this one, and I've already done it, rather than clicking in my alignment by hand, if I just wanted to use that surveyed alignment, when I started the software, I would have clicked New, Horizontal Alignment, and I would have used a reference feature. So in this case, it's C001. So that gives us an alignment that is a duplicate of that surveyed feature. And then, so there we are. The default cross-section geometry is applied. I would come in here. Now this widening component or widening template isn't a default one. I pulled in a few different widening component or a few different components from the E library. I've got my widening set that the existing ACP width is 3 meters, and I want to move it out to be 3.5 on either side. Now, if we wanted to use a reference feature, so surveyed edge of road, rather than using a fixed width, we could reference a surveyed feature in here. But yeah, we'll hit cancel since that's already there, and we'll click assign by range, and we'll apply our widening template to the road. And if we wanted to apply different templates along the length of our road, we could here. I'm just doing it for the whole thing. So station dot dot to dot dot. and we'll hit OK. And there's that. So our cuts are representing the additional ditching that's happening. Our center line set right on the surface, which we'd like. And there we go. Next question. Is it possible to state the number of section views you would like to the output per page, say 4, from the demo I see produces numerous section views? So absolutely. And I'll come back to the one that I put together in front of everyone rather than using something else. So with this, in this section view, I've got all sorts of cross sections. Now, the way this behaves is going to be based on how frequent the cross sections are modeled in the software. And quite often, in order to get reasonable volumes and rendering of what we're working with, we're going to want more than just cross sections at certain intervals. So you're going to want to include cross sections being calculated at your beginning and end of curve, where templates change, but you culverts, anywhere that there's something notable going on. But you probably don't want all those intervals included in your cross section. So with this, I've got mine set to include 4 rows, 3 columns. If I wanted that to be 2 by 2, I could just set 2 by 2. And there we are. Now we still have a lot more pages. And I've got 0, 20, 40, 60. So let's go back into layout and point types. So I'm telling the software, I want to see cross sections every 20 meters and wherever I've inserted a culvert. Now, if I want to include more information or less information, I can. So we could choose any one of these point types where the cross sections are being generated. And I'll use a different class of points here. So I'll use 100 meters, so I'll get fewer cross sections. And let's say instead of 100 meters, let's say I wanted them 50. So rather than that number, I've highlighted what I want, clicked properties, come in here and I'll change it to 50. And I'll include my culvert insertion points because usually culverts are interesting enough to warrant a cross section. And there we are. So now we've got 0, 50, 100, 150. And if we cycle through here, forget where we added that culvert. There's our culvert, and we're at 1520. So it adds a point at that class of, or cross section of that class of points. And similarly here, whoops, if I come in, select all, turn all these on, anywhere the cross section is being, or a report point is being generated, we've got a cross section now. So 93, 100, 120, etc. Yeah, so absolutely, there's all sorts of flexibility in what's reported, and we can also change the range that is included in that. So I'm including my cross sections for the entire road. If we want to hem that in to just include a certain section, we can isolate what these chapters account for. So if we wanted to go from 0 up to, say, 500, what's included gets smaller. And with that, yeah.
Hey, Matt, we did have a couple other questions that actually came to me through chat.
Okay.
So the first question is, what does the alpha channel represent?
Oh, okay.
You clicked it at one point, and I think, yeah, we could just explain what the alpha channel represents.
Absolutely. And our 3D view is a super useful tool. It's dynamic. It's nice to work with. So I will expand a little bit on the 3D in general. Working my way to the alpha channel. So in this view list, you can have multiple background files. Current's going to represent your current alignment. So we can expand that, and we can control how that's being modeled in here. So I've got culverts turned on, for example. If I turn them off, we won't be able to see our culverts. If I turn off boundary, we'd get funny triangulation where the surface doesn't know that we want to end the road at the edge of the cuts and fills. And we've got this other surface for our topo. So I've turned on display triangles, shade triangles. Now, if I didn't change my alpha channel, so by default, that's going to be 255. It's fully opaque. So the alpha channel really is just a means to control transparency. So if I want to see what's happening in my ditch line or anywhere where I am in cut, I'm going to control the surface so I can see through it. So 255 is fully opaque, 0 is fully transparent. To get a good rendering, usually want somewhere around halfway between those numbers. Yeah, and if we go closer to 255, it'll be darker, and that'll be that. So there we can see now inside our cuts and fills. And just another couple items that are nice to work with here that may not get clicked right away if you first jump into the software. It's nice to have track mouse turned on. So with that track mouse, if I need to just find where I'm at. If I have my cursor in here, in my plan view, I can see where I'm at in the 3D view. And same can be said in the profile. So it just shows, regardless of which window you're looking at, where your cursor is at in the 3D view. And another item that's nice to turn on is dynamic redraw. So with this, as I change my alignment, and I've got curves butted right up against each other. So if I change my alignment, that's automatically accounted for, whereas if I had dynamic redraw turned off, it doesn't know that's been changed, and I have to click update 3D display list to make the change. So hopefully the alpha channel solution and some of the other functionality folks find useful.
Excellent. I've got two more, Matt.
Yep.
One of which actually is more of a me question, which is lovely, which is how do I download the software after the webinar? To answer that question, we will send you all a link. We can do it actually here in the meeting. I can do it through the chat, send a note to everyone, as well as we'll include it in our follow-up email. The more interesting question, though, however, it says with rural roads, we most of the time have to select routes and have alternates. Does this software have features to select alternate routes?
Oh, absolutely. I like that question. That plays right into our hand. So we absolutely do. Now with this, so I've got my preliminary alignment set up. We can do multiple alignments in here. So I can right click, new horizontal alignment, and we could either start entirely from scratch, or we can click duplicate from. So if it was a question of, let's just look at what we have going on here. Is there, yeah, whether we track the existing route through this village, or if we bypass it on the outside, well, in that case, instead of starting from scratch, I'd want to click new horizontal alignment, duplicate from. So we'll just duplicate our current alignment. And actually, I'm going to use this as our current, just so I don't have to move around curves that have been butted up against each other. So new horizontal, duplicate from horizontal alignment 1. So we've got 2 identical alignments right now. And let's just pull this up here. So that one, as designed, is 242.6. And now I'm off the surface, so I can't really do what I'd normally do. But if we had survey data over here, we could re-optimize it, and we could see, okay, which one of the 2 optimized alignments is cheaper. And make a really informed decision on which is our best route. So the short answer is yes, and the medium answer is yes, we're really good at it, and then long answer is yes, we can either draw one in from scratch, duplicate alignments, and use the two as a comparison. Our design time costing functionality really helps in a quantifiable approach to choose the best solution, and optimization really helps to eliminate any designer bias when making that decision as well. So if you design two alignments by hand and you just happen to do a better job at designing one of the alignments, it can often influence which one's best, and then you spend a bunch of time chasing down the alignment that actually wasn't the best alignment, because if you optimize them, you could have actually gotten the cheapest cost, and that difference between a good by hand design and an optimized design can influence which one's the better solution.
Awesome. Well, I think, Matt, unless you had anything else you wanted to show, I'm just going to steal the screen back here for a second.
No, that works for me.
Yeah, so I just wanted to sort of reiterate. I know we had a whole bunch of people came towards the middle and the end, and yes, everyone kind of starts at different times, but I just wanted to reiterate my thank yous. So again, thank you to our partners at KeyCam Technologies. They are official distributors of ours in Nigeria. And yeah, thank you very much for helping us to put this seminar on. And again, thank you to the Sierra Leone Roads Authority for the gracious use of your data at a relatively last minute notice. So thank you for that. Matt, we do have some more questions coming to me over chat. Perhaps what we'll do in this case is follow up with them directly. Yeah, and we'll kind of leave it there. So to the additional question askers, we'll follow up with you. And to everyone who took the time today to, yeah, spend an hour with us to learn a little bit about a rural road design workflow in RoadEng, thank you for your time. We really appreciate it. Have a wonderful day, everyone.
Thanks, everyone.